Procurement needs public rules and accountable awards, but vendors should not have to reveal their commercial terms. FlareQuorum combines private bids with a publicly verifiable award on Flare. The product covers the complete journey: fund a tender, freeze its rules, collect sealed bids, compute the winner confidentially, and settle the public award. This demo uses finalized cost-in-2 state and FTestXRP with simulated confidential compute machines and explicit test boundaries. 5 workspaces, separate responsibilities. Public exposes evidence. Buyer creates tenders. Private bids protects vendor input. Activity advances checkpoints. Auditor verifies the binding. Confidential competition happens inside the fixed machine quorum, while public coordination records lifecycle and settlement checkpoints. Here the landing page answers the common privacy and trust questions. It then invites anyone to inspect the evidence before connecting a wallet. Docs is the product and technical guide. It covers the current release, Judge Quick Start, Flare integrations, buyer and vendor flows, XRP funding, recovery, privacy boundaries, and verification. The guide connects each technical checkpoint to the user journey. Now I return to tenders and begin in public. It is read-only and wallet-free. A judge can inspect finalized evidence before signing anything. The tender list exposes the public brief, escrow ceiling, deadline, approved vendors, scoring policy, and lifecycle state. The dossier freezes 3 machine identities and their key fingerprints. Every accepted bid must reach the same 3-machine receipt quorum. Public commitments form a canonical ordered route, and closing binds the official XRP to USD price checkpoint. Until confidential computation finishes, losing bids remain private and the result stays pending. Buyer offers 2 funding paths. Fund from a cost-in-2 wallet approves FTestXRP and opens the tender directly. Fund from an XRP wallet is the advanced XRP native path. It prepares an XRPL payment, then hands off FDC proof and Smart Account funding. In this demo, I choose Fund from a cost-in-2 wallet so we can focus on the confidential bidding and award flow. First, I connect Wallet 1 as the buyer. MetaMask keeps signing in the user's wallet, and the application confirms cost-in-2 before enabling creation. I create a website procurement tender, starting with its public title and category. The escrow ceiling is 10 FTestXRP, and the deadline defines when bidding can close. The objective and acceptance criteria are public, so every approved vendor competes against the same requirements. Next, I add the public question each vendor should answer, their delivery plan, and the warranty support included in the offer. I then approve exactly 2 vendor wallets. Eligibility is fixed in the tender rules, so an unapproved account cannot enter the sealed bid path. Scoring must total 100%. With warranty set to 10, the total falls to 90, so the action stays disabled. I correct warranty to 20, producing 60% price, 20% delivery, and 20% warranty. Only at 100% can I approve and open the tender. Wallet 1 approves only the required 10 FTestXRP allowance. Private bid inputs never enter this transaction. The next transaction creates Tender 13. The interface waits for 12-block finality before treating the event as canonical. Back in public, the app reloads finalized cost-in-2 state instead of trusting browser memory. Tender 13 now appears with the title 10 FTestXRP escrow, 2 approved vendors, matching rules hash, and open status. Its dossier exposes the frozen confidential compute envelope, 3 machines, the common receipt policy, deterministic scoring bounds, and the ordered route checkpoint. No bid has been submitted yet, so the correct public state is result pending. There is no client-selected placeholder winner, and losing bids remain private. I open private bids, then switch MetaMask from the buyer to the first approved vendor. The private commercial form is available only to an eligible account. Vendor 1 selects Tender 13 and reviews the same public brief, ceiling, deadline, and service bounds defined by the buyer. The vendor enters a synthetic quote, delivery time, warranty, and response. These working values remain in the current browser session and are checked against the public bounds. The final review is still private. Encrypt and submit creates one ciphertext for each fixed machine. Plain text is not sent to the chain. The vendor signs a narrow ingress authorization for each encrypted copy. Each machine validates the same tender and vendor domain, then returns a signed custody receipt. All 3 receipts must agree before the public commitment is submitted. After finality, Track Your Submissions shows the first commitment with a 3 of 3 receipt bitmap and accepted cost in 2 block. The interface cannot reopen the private terms. I now switch to Vendor 2. This wallet loads the same tender but enters a distinct synthetic offer. The identical ceiling, delivery range, warranty range, and eligibility checks apply. The second vendor repeats the canonical path, in session review, 3 machine-specific ciphertexts, wallet-bound authorizations, signed receipts, and 1 public commitment. Privacy applies to every accepted bid. I accelerate only this network wait. Receipt verification and finality requirements remain unchanged. I return to public. Once finalized state loads, both vendor commitments appear as public bindings without exposing commercial payloads. Next, I open Activity, the permissionless public coordination workspace. Tender 13 is ready to close because its vendor quorum is present. Activity advances checkpoints, but cannot decrypt bids or choose a winner. The closed transaction freezes the rules hash, ordered bid route, common machine quorum, close block, result nonce, and official FTSO snapshot. The next checkpoint dispatches the frozen selection request. MetaMask confirms the public instruction and FCC fee. The caller receives no bid decryption capability. The activity card now polls for matching signed results from the fixed confidential compute machines. Only result polling is shortened here. No fallback winner is inserted. I select check 2 of 3 and finalize. 2 distinct fixed machines must sign the exact same result bytes. The contract verifies the full result domain, finalizes terminal state, pays the winner, and returns the buyer's remainder. Activity now shows every checkpoint complete. I return to public. Once finalized state loads, Tender 13 appears as awarded with the winner, payout, buyer remainder, result digest, and award receipt. Finally, I open Auditor to inspect the binding, not the bids. Auditor has no signer or decryption route. It verifies the public rules, 3 machine custody, 2 accepted commitments, matching result signers, price checkpoint, and settlement outcome. This is unaudited cost in 2 software using simulated TEs, not hardware-backed or production security proof. What it demonstrates is confidential competition, deterministic selection through the FCC path, and an independently checkable public award.